My name is Owen King, and this is my presentation on wired versus wireless networks. The objectives are going to be compare wired and wireless networks, discuss the difference at the physical and data link layer between IEEE standards and the OSI model, compare security risk on wired versus wireless networks, describe unique security and operational attributes in the wireless environment and their effects on network communications, examine the mitigation strategies and tools that can be implemented to lessen security risks associated with wireless networks. IEEE standards. The IEEE is the Institute of Electrical and Electronics Engineers. IEEE 802 Local Area Network and Metropolitan Area Network Standards Committee was formed in 1980. The Standards Committee is a major working group chartered by the IEEE to create, maintain, and encourage the use of IEEE and equivalent International Electrotechnical Commission and International Organization for Standardization, IEC or ISO, standards. This was developed by the IEEE 802 Standards Committee, developed the family of standards, the 802 family of standards. MAC and physical layers of the 802 standards were separated from the logical link control standard because of their interdependence between medium access control, medium, and topology. As you can see, the OSI model differs from the 802 standards model basically in the physical and data link layers. So the IEEE standard subdivides the OSI data link layer into two sublayers. Wireless LANs provide functionality that correspond to layer 1, the physical layer, and layer 2, the data link layer of the OSI reference model. As you can see, there's some overlap between physical and data link. That 802.11 standard, it also includes the logical link control. The remainder of the model is the same for all the higher layers. The 802.11 MAC sublayer resides within the data link layer and enables multiple client devices to share common air transmission medium by using a carrier sense protocol. This carrier sense protocol coordinates access to the various devices, or stations as they're known, can share the same frequency and space in the RF spectrum. 802.2, the logical link layer, is the highest layer of the IEEE 802 OSI reference model, provides similar function at the high-level data link control, known as the HDLC. Its purpose is to exchange data between end users on the LAN, provides addressing and data link control, independent topology, transmission medium, and medium access control utilized. Essentially what this is showing is that this layer 2 of the data link is kind of split between that medium access control and the logical link layer. Then layer 1 makes up the various 802.11 standards. Security. Wireless networks are only accessible with a physical connection. Wired networks are only accessible with a physical connection. Wireless networks are accessible as far as the range of the Wi-Fi signal. For considering various security protocols, the following is true. Take two closed networks as an example. One's wired, one's wireless. Neither can be accessed from outside the network. The wired network would require a potential attacker to physically enter the building and connect to the network. Now, there are a couple examples outside of this, but for the most part, this is true. The wireless network could be accessed from a parking lot, covertly using a device with a Wi-Fi connection without entering the building. With a wired network, access to the network requires a physical cable connected to a port which has access to that network. A wireless network is accessible in the range of the RF signal being transmitted to supply the connection. This allows potential hackers to attempt to connect to the network from outside the confines of the building where the network is located to use that to gain access to the network. Vulnerabilities exist in a wired network, but they are not as easily intruded upon. The hacker would need to use sensitive listening equipment, but would need to be very close to the cable, and would be much more likely to be detected. Security vulnerabilities. Service set identifier, rogue access points, denial of service attacks. The SSID, service set identifier, identifies a specific wireless LAN. Before associated with a particular wireless LAN, a station must have the same SSID as the access point. By default, access points include the SSID in the beacon frame to enable client station to find the wireless LAN. Some access point vendors have an option to disable the SSID from being broadcast in beacon frames to reduce security issues. Rogue access points. So a common example of a rogue access point would be maybe an employee wanted to improve the Wi-Fi signal to their portion of the office, and they decided to purchase an off-the-shelf wireless access point and install it in the office. The issue here is because the rogue access point was not installed by the IT staff, it might result in security vulnerability, maybe set up in a way that the IT staff would not have, that allows a specific vulnerability that a hacker may use to access the network. Just any kind of thing like that. Finally, we have denial of service attacks. Wireless networks are especially vulnerable to denial of service attacks. They're also susceptible to unintentional denial of service by having too many devices which may be connected to the network or operate upon the same band, such as wireless phones, Bluetooth devices, or just too many wireless devices connected to the network at the same time. So, wireless security considerations: encryption, authentication, rogue access point detection, and radio frequency shielding. Encryption is necessary because it scrambles the data bits from an 802.11 frame to keep unauthorized people from seeing the actual information content of the frame. If there's no encryption, then this is available in plain text and will be easily accessed by a hacker. There are various different encryption standards, which we'll discuss later on. Authentication ensures that client devices connecting to an access point are authorized to access protected resources. Rogue access point detection. Sometimes employees or hackers may purposely or mistakenly plant a rogue access point, as discussed previously, that provides an open access to protected resources. Finally, radio frequency shielding. Consider using RF shielding paint to window film to highly attenuated radio waves and minimize spillage of signal coverage outside the control areas. Basically, the idea would be to block the RF from entering into the building. While this has benefits of preventing Wi-Fi signal from getting outside the building, it also has plenty of downsides. Wireless networks are incredibly convenient, allow for network flexibility and convenience, which leads to greater productivity. Another great example is if you have a guest network, you can break this into a subnetwork that allows you to have an easily accessed guest network, which may be necessary for many consumer businesses, retail, restaurants, coffee shops, things like that, where people expect to be able to connect to the network. Wireless LANs intentionally propagate data using RF signals, which go outside the area which they are intended to cover, which makes them susceptible to passive monitoring. So when using a packet sniffer, a hacker will be able to intercept the 802.11 transmissions without being detected, which is a security vulnerability. Encryption standards, as we mentioned, are necessary to protect your Wi-Fi network. They're going to be the most common defense against potential hackers. WEP was part of the original 802.11 standard. It was at the time the standard for wireless encryption. WEP was discovered to be easy to crack and has been the subject of many breaches. The TJ Maxx's parent company breach in 2009 is a great example of a company using WEP encryption well after it was discovered to be vulnerable, and has resulted in an intruder having access to the network for 18 months undetected. So WEP is not necessarily the standard in use anymore. It's been mostly replaced by Wi-Fi protected access known as WPA, various WPA standards, as the most commonly used and default wireless encryption standard. Protecting against vulnerabilities. As mentioned earlier, a denial of service attack is a potential vulnerability. If it's an anticipated issue, there's a few options on a wireless network. You can use kind of the RF signal, RF shielding as a potential protection against denial of service attacks. You can minimize the possibility of these attacks by blocking those incoming radio signals. This can cause peripheral issues such as loss of cell signal and just general inconvenience. Radio signal interference causes wireless clients' access points to hold off transmitting, which causes delays and reduced throughput. This results in decreased network performance and in turn decreased productivity. Cordless phones and Bluetooth interference are an issue as they both operate in the 2.4 GHz band. This needs to be considered when designing a network. Though Bluetooth hops throughout the bands, it can still possibly be potential interference. Even when all vulnerabilities are actively being protected against, there's always a need for a backup plan. A wired network should be available should the wireless LAN fail. In some retail environments, you may need an alternate method of taking payment and giving receipts. In general, you should have some way of being able to continue your business in the case of a wireless LAN failure or issue. Thank you.